The next model question related to Gauss divergence theorem. Use Gauss divergence theorem to evaluate integral over s f bar dot ds bar, where f bar is given as x cube I bar plus y cube j bar plus z cube k bar, and s is the surface of the sphere x squared plus y squared plus z squared is equal to r squared. So from the sphere you have to evaluate the vector point function over the surface integral s. So already we know f bar is written as f1 I bar plus f2 j bar plus f3 k bar. So by comparing these two, you will get f1 is equal to x cube, f2 is equal to y cube, f3 is equal to z cube. By Gauss divergence theorem, integral over s f bar dot ds is equal to volume integral div f bar dv. So you need to find div f bar. So for div f bar, what is the formula? Dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So you have to differentiate this f1 with respect to x partially, and f2 with respect to y, and f3 with respect to z. By differentiating partially this, you get 3 into x square plus y square plus z square, that we have substituted in the divergence theorem. Next, the polar coordinates of the sphere is as x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. So here dx dy dz is as r square sin theta dr d theta d phi. For the sphere x square plus y square plus z square is equal to r square, the limits are r is from 0 to a, theta is from 0 to pi, and phi is from 0 to 2 pi. So this polar coordinates of the sphere already you studied in the previous semester. From the divergence theorem, if you substitute all this data, you get the volume integral from x r 0 to a, integral from theta 0 to pi, integral from 0 to phi 0 to 2 pi. That then substituting in that 3 into what we have here, x square plus y square plus z square, and that is given as the radius r square into dx dy dz is equal to what we have, r square sin theta dr d theta d phi. So that we have substituted in this, and firstly integrate with respect to phi, and then respect to theta, and then integrate with respect to r. So first we are integrating with respect to phi. There is no phi function in this, so we'll get only integral d phi as phi, and the limits 0 to 2 pi. Next, integrating with theta, the limits 0 to pi. So here theta function is sin theta. So sin theta, if you integrate, you get minus cos theta, and the limits 0 to pi. Next, coming to the next integration with respect to r dr. So here you have integral 0 to a r power 4 dr, and the remaining value for that integration is 12 pi a power 5 by 5. So this is the question related to polar coordinates of the sphere. Next, small 2 marks question, that is using divergence theorem, evaluate integral over s x dy dz plus y dz dx plus z dx dy, where s is x square plus y square plus z square is equal to a square. So this is also sphere. Now in this comparing f1 as x, f2 as y, and f3 as z, by partially differentiating with respect to x for f1, with respect to y for f2, with respect to z for f3, you get those partial derivatives as 1. Then you will have div f bar is equal to 3. So by Gauss divergence theorem, if you substitute this div f bar dv for this volume integral, you get 3 dv. So for this integral dv we get as v. So this V is the volume of the sphere with the radius given in the sphere as A. So the volume can be written, that is 4 by 3 pi A cube. So this is the answer for this volume of the sphere. So substituting in this, you will get 3 gets cancelled, then you left out the value 4 pi A cube. That's all. Thank you.